Можно стартовать, да? Запись.
Я вырежу вначале.
Хорошо, спасибо огромное. Good morning, everyone. Today we are having a lecture dedicated on forensic toxicology. Today we would discuss general concepts of forensic toxicology, classification of different toxicants, sources and circumstances of intoxications, conditions of actions of toxins, and different ways of administration and elimination of toxic substances in the body. Toxicology in general is the science which deals with identification and quantitative determination of toxic substances. It studies chemical properties of these toxic physical-chemical characteristics. It studies mechanisms of action within the body and consequences of action of toxicants. It also studies signs and symptoms of intoxications and methods of isolation and treatment, and also antidotes use in case of intoxications. The word toxic comes from Greek word toxikon, which further turns to toxa, which means an arrow which penetrates the body, kills someone. But also toxicus, as a result of that, could be translated as damage, destruction. And some idea also says that the word toxic comes from the Latin name of the plant Taxus baccata, which contains alkali toxin, shown in a picture. Toxic or toxin or venom or poison sometimes is a substance which penetrates to the body from outer environment in a small quantity, this is important, and under certain condition. And via chemical or physical-chemical action, it might cause death or health disorder. Health disorder or death, together the complex of symptoms, signs, morphological changes caused by the effect of toxin are known as intoxication or poisoning. What's important, intoxication or poison, is the reaction of the organism to the administration of toxin, because different organisms could react in a different manner to the same poison, to the same amount of poison, same concentration. And that's why we always must discuss it. We always must consider poisoning as reaction of the body, which is highly dependable on the body and other circumstances of the particular poisoning. Different poisons could be divided to 4 groups by the mechanism of action. By the action within the body. These are corrosive poisons, destructive poisons, hematic, and functional. The word functional had been shifted a bit, but anyway, functional poisons are the 4th group of poison which also belongs to this classification. Corrosive poisons, they have caustic characteristics, they cause marked, pronounced morphological changes. But these changes are mainly local. Corrosive poisons, they mainly include acids and alkalis. Destructive poisons are severe intoxicants. They cause serious damage to the particular target organs. mainly. It also might cause some local changes, but via absorption and following the distribution within the organism, they basically damage target organs. Hematic poisons. These are poisons which cause changes to the blood components. These changes of the blood components disabling blood from transporting oxygen or transporting other substances. The most known hematic poisons are carbon monoxide, which blocks hemoglobin binding sites, preventing hemoglobin from binding with oxygen, and different nitric substances causing damages to hemoglobin molecule and also disabling hemoglobin from transporting oxygen. Functional poisons, fourth group, is the large group of poisons which mainly block enzymatic changes. In difference to the destructive poisons, functional, they start affecting biochemical processes. If destructive poisons, they destroy cells and tissues themselves. Functional poisons predominantly block enzymatic changes, and the destruction of the tissue also might take place, but secondary destruction as the result of functional blockage of enzymatic reactions. Circumstances, source and circumstances of intoxication, from where the one might get intoxicated. Ingestion of poison, administration of poison could be intentional, as a homicide by poisoning, as a suicide, and in case of toxicomania, then someone takes poison constantly, chronically, and this chronic intoxication or repeated administration might cause accumulation, leading to toxic manifestations. Administration of poison might be involuntary or accidental. It might be accidental in itself, then one ingests toxin as the result of carelessness, ignorance. It could be as a result of drug consumption, for example, medical error, wrong prescription, wrong of the dosage as the result of medical mistake. Professional intoxication, it might be industrial or agricultural due to exposure to poisons which are used in particular industry or particular field of agricultural area. And food intoxication. Food intoxication is the consumption of poisonous food or beverages because the food is poisoned due to bacterial contamination, or maybe it was poisonous originally. Condition of toxic action. What affects the action of poison? What affects finally poisoning as the process? Poisoning depends on substance which is introduced to the body. It depends on the body itself. It depends on the way of administration, and it depends on behavior of toxin, behavior of poisoning within the human body, so-called toxicodynamics and toxicokinetics of the particular substance. What conditions depend on substance itself? First of all, origin of substance. If the substance is extracted from not recommended food source, it could make them toxic in origin. For example, the food source is salt initially, and if we administer such a food, one might get intoxicated. Conditions dependent on substance also include age of this particular substance. because the agent, some substances might get less poisonous, but some of the substances might get even more poisonous characteristics. Also dependent on dosage of substance. Dose of substance is the amount of the substance which can produce a particular result. We basically distinguish so-called therapeutic, toxic, and lethal doses of the particular substance. Therapeutic dose is the dose used for therapy to treat certain conditions. Toxic dose is the dose which has a harmful effect on the human body. And lethal dose is the dose which usually lead to fatal outcome. Concentration. Concentration might change the effect of particular toxin. For example, sulfuric acid, if diluted, might be used as antidote, might be used as beverage, might be used even as kind of treatment. But concentrated aggressive sulfuric acid is the highly poisonous corrosive substance, which leads to serious effects on the human tissues and human bodies. So harmful outcome is highly possible. Conditions which are dependent on the substance include physical state. If the poison is gaseous, it could be administered easily while inhalation. If it's liquid, it also enables many ways of administration, many routes of administration. Solid substances are hardly penetratable. They also could be consumed, they could be administered, for example, intraorally, but anyway, the same substance, if it's solid, is less poisonous. Conditions of the effect of toxins which are dependent on the body of the human. These are age, gender, body weight, individual predispositions, hypo or hypersensitivity to this particular toxin, and habituation to toxin. Younger people, children, adolescents, elderly people, they are usually more vulnerable to particular toxins. Sex of the human is also one of the factors which determines the effect of the poisons. Women could be more predisposed to certain toxins, like for example, to the toxic effect. Like for example, ethyl alcohol. Women are more vulnerable for it. Body mass, body weight is the factor which also could determine the effect of poison, because distribution of the poison is different. But at the same time, the higher body mass usually associated with a particular health disorders, which also could be predisposing factors to the harder poisoning effect. Individual predispositions, they are dependent on many aspects of the body. This could be individual predisposition to be poisoned with certain particular toxic substances, and if the one has idiosyncrasia to it, this predisposition might be very harmful for the one. Hypo or hypersensitivity to toxin is very individual and hardly prognosable. And habituation to toxin could be seen in case if one consumes this poison in a repeated manner and regularly. And the one is being accustomed, trained for it, to resist it. It leads to rise of the amount of the enzymes resisting these toxins, metabolizing these toxins. And in this case, one might get less intoxicated, like in case of consumption of ethyl alcohol once again. But at the same time, if these enzymatic systems resistant poison are being exhausted, in this case, if they are depleted, even little amount of the particular toxic substance might lead to the fatal outcome, fatal effect. Conditions which are dependent on the body, so age, gender, health status. It determines rate of absorption, rate of elimination, transformation of the toxin in the body. For example, people that have the liver failure, they are more vulnerable to several toxins because these toxins are metabolized within liver, and if liver is damaged, is impaired, this is obviously the factor which becomes, which makes every poison hard. Hypersensitivity to particular toxin could be acquired or congenital. Excessive susceptibility is called idiosyncrasy, which is sudden, rapid reaction to the particular poison. It differs from allergy in that aspect that allergy usually requires some initial primary contact of a substance to be sensitized. In case of idiosyncrasy, it cannot be prognosed. Even the first contact with a particular poison might be very dramatic on its consequences, and outcome could be drastic, sometimes even death, fatal exodus. Hypersensitivity, this is diminished reaction of the body to the toxin, also might be congenital or acquired. It depends on many factors, but mainly these are enzymes. These are enzymes which are usually metabolizing particular toxic substance. Depending on it, it might differ. Habituation to toxin is seen in case if one consumes poison in low dosage, but if this dosage is gradually increased, it might lead to a customization and training of this particular substance. And the one, if being trained in such a manner, could even consume larger amounts of toxins with no serious consequences. Routes of administration of the toxic substance to the body, they could be direct or indirect. Direct poisons, direct route of administration is the direct contact of the blood. It could be hypodermic, intramuscular, intravenous, intraarterial. These ways are rapid and more dangerous if we are talking about poison. Indirect, with no direct contact of the blood, routes of administration via gastrointestinal tract, respiratory tract, but what's important, via respiratory tract, people usually inhale gaseous substances. These gaseous substances, if penetrating easily via barriers within the alveolus, they could get to the blood flow in a rapid manner. And transcutaneous method of administration means penetration via intact skin, not damaged, not punctured. Just the skin which is intact, but if some certain substances, they have properties and characteristics enabling them to penetrate via intact skin, it also might lead to the particular symptomatic intoxication. But usually, this indirect route of administration is less dangerous, is not that rapid, slower, and it is widespread. It is definitely much more distributed compared to the direct contact of the blood. Corrosive substances. A bit of information about the particular toxins. Corrosive substances are the substances which have mainly local effects. They have irritating effect, lead to necrosis and fusion within the tissues. These corrosive substances are represented by acids, alkalis, phenol, formalin, hydrogen peroxide, potassium permanganate, and other substances, the irritating action. Usually these substances are administered orally, and at the site of the first contact they already affect human body. They lead to severe chemical burns and produce necrotic changes to the tissues they contact with. Acids are the substances which have molecules, and these molecules in aqueous solution dissociate the production of positively charged ions of hydrogen. These ions of hydrogen, they absorb water from the tissues, so they produce solid hard necrosis. Most common way of administration is per oral administration. Then it is consumed in accidental manner, with no intention, or sometimes with a suicidal intention. In rare cases, inhalation is possible, or some kind of transcutaneous or transmucosal penetration. Ions of hydrogen, it captures water from the tissues, coagulates proteins, produce acidic albumins leading to acidosis, and they denaturate proteins. So they not only change the structure of the protein, but they destroy protein to fragments, to pieces, or different acids might produce different effect. For example, nitric acid produces so-called xanthoproteinic reactions, then proteins, the cyclic amino acid, they form particular nitric compounds of yellowish color. And that's why in case of poisoning with nitric acids, we mostly see yellowish color of mucosa and sometimes skin. If hydrochloric acid or sulfuric acid is used as a poison, we commonly see production of temperature of heat, and some thermal action, traces of thermal action might be seen on mucosa. Especially sulfuric acid produces severe chemical burns, severe chemical necrosis, with blackish coloring of the surface which is being exposed to the effect of the sulfuric acid. Arsenic acid, it has high resorptive properties. It's organic acids and differs a bit from other representatives of this group. This organic acid is used in certain domestic activities, used for cooking, and might be accidentally taken orally as a concentrated solution. Due to high resorptive properties, it might be absorbed and get to the blood flow, leading to severe acidosis and hemolysis. Morphological appearance of poisoning with acids. At the acute period, we basically see chemical burns of coagulated hard necrosis around the mouth and along the digestive tract. We also might see local inflammatory reactions. Within the delayed periods, we see stomatitis, esophagitis, gastritis, mediastinitis, peritonitis as the result of penetration and sometimes perforation. We also might see pneumonia as the result of evaporation of toxin from the digestive tract and inhalation of it to the respiratory area. Some dystrophic changes due to impaired function of the digestive tract due to malabsorption. And these dystrophic changes might be seen in different inner organs. Morphological appearances manifestative coagulative necrosis, which is relatively hard and dry due to dehydration of the tissues. But this necrosis is relatively superficial because of the hard condition of the necrosis, because of dehydration. Penetration of the acid in a deeper tissues is usually stopped by the crust, which is being formed on the surface of the necrotic area. On the surface, we commonly see rough crust covering the entire surface of the chemically burnt area. This area of the chemical burn is surrounded with the zone of the local inflammation. Color of the tissue at this area might be dark brown or brown black. Sometimes it could be dark red due to multiple hemorrhages. In case of poisoning with sulfuric acid, we mostly see deep necrosis, brown, black in color. Nitric acid produces yellowish coloring. Hydrochloric acid has dirty gray color of the damaged area. Acetic acid is diagnosed by a specific odor, and because the area which is being damaged, which is being exposed to sulfuric acid effect, is edematous, and digestive tract has dark red color because inhibited with pigments. Oxalic acids and phosphoric acid, they produce severe hyperemia of the mucosal membrane with multiple dotted hemorrhages. Alkalis. Alkalis are the substances containing hydroxyl group, OH, and the anion of metal. This OH group affects the tissues, and anions do so, but they change the charge of the tissues. Same ways of administration are same, usually per oral, dominating route of administration, but might be via inhalation or some transcutaneous or transmucosal administration. Hydroxyl group affects the tissues with production of edema because it attracts water anyway, but it merges and dilutes the proteins. So due to its high solubility, alkalis usually penetrate to the deeper underlying tissues, deeper beneath the mucosa. And that's why necrosis produced by strong alkalis is usually more distributed and has more complications. Strong alkalis, as you can see, they also might affect underlying tissues, not only because of the skin it contacts with. Morphological appearance of the changes seen in this particular case is a deep, so-called colliquative soft necrosis. This necrosis looks like a jelly of opaque color, whitish and grayish color, with no clear demarcation zone, with a marked edema and tumefication of the tissues. Mucosal folds of the area of stomach or intestine, they might disappear. Color is usually white-gray, but sometimes greenish, sometimes brownish color due to hemorrhages. In delayed period, multiple ulceration is usually seen on mucosa of the digestive tract organs, and these ulcers, they might perforate. That's why such complications as mediastinitis, peritonitis are very common for poisoning alkalis. Pneumonia also might be seen as the result of penetration of such alkalis to the ear pathways. And dystrophic changes in the organs are related to severe alkalosis. Destructive substances, few words about them. Destructive substances, next group of poisons. These are substances which cause mainly destruction due to dystrophic effect, necrotic effect, destruction of the internal organs like kidney, liver, myocardium, or other organs. Representative of destructive substances are heavy metals and metalloids, they compounds like arsenic. Hematic substances are the substances, as I've said, which mostly affect the ability of the blood to transport oxygen. Carboxyhemoglobin is the complex of hemoglobin and carbon monoxide is not able to transport oxygen. That's why such a blockage, information of carboxyhemoglobin, which is not dissociating, not permitting oxygen to replace carbon monoxide and blocks the transport of oxygen, leading to severe hypoxia. Methemoglobinic substances, they change the structure of hemoglobin itself, not blocking it, but changing it. Due to changing of the molecular structure, hemoglobin would not be able to transport oxygen anymore. Other subgroup of hematic substances are substances which change not the structure of hemoglobin, but structure of erythrocytes. These are hemagglutinative substances leading to agglutination and sometimes coagulation. Hematopoietic substances, they block production of the blood cells. Hemodynamic substances, blocking transportation of the blood via vessels. And functional poisons. The most known representative of the functional poison is the ethyl alcohol. There are also some surrogates replacing alcohol. If the one consumes alcohol-based tinctures or alcohol-based water solutions, these or lotions, these surrogates are of relatively low risk. Technical liquids containing alcohol are the medium risk substances, and some high risk substances are molecules which are similar but not the same, not containing ethyl alcohol but similar molecules, like methanol solution, ethylene glycol solution, or dichloroethane. These solutions, they might have similar appearance to the ethyl alcohol, similar odor, even taste, but due to severe difference of the substances from ethyl alcohol, these effects might be much more pronounced and sometimes even fatal. Alcohol intoxication and is realized via certain mechanisms. Mechanisms of action of alcohol include depression of central nervous system, narcotic action in case of dichloroethane, neurovascular effect in case of methanol, and different toxic metabolites of these substances, they also might produce toxic effect. Intoxication by alcohol and its surrogate could be clinically manifested, but usually diagnostic biochemically. If the amount of alcohol is up to 5 per mile in the blood, not concentration of alcohol, up to 5 per mile, not percent, but per mile. If percent is 1 from 100, per mile means 1 from the 1,000. Up to 5 per mile is the insignificant influence of alcohol. This is a sober person. If the concentration of the ethyl alcohol within the blood is starting from 0.5 to 2.5 per mile, this is a medium level of alcoholic intoxication. From 2.5 to 3 per mile, this is severe alcoholic intoxication. More than 3 per mile, this is a very severe alcoholic intoxication, which in certain predisposing conditions might even lead to death. And from 5 to 6 per mile of alcohol, this is a fatal intoxication, usually leading to the death of the patient. If we find more than 10, more than 15 per mile of alcohol in a sample, this must force us to consider sample contamination. Maybe the tube or the vial which was used to collect the sample of the blood for laboratory analysis of the alcohol was previously used to store some alcohol-containing liquids and was not washed properly. You must take this to account because such a concentration is almost non-accessible for the human. One cannot drink that much. Well, for the two-day lecture, brief lecture, this is the very brief introduction to the forensic toxicology, and this lecture is over now. Thank you for your attention. See you in 2 weeks at the last finalizing lecture, and see you at the department in the practical classes. Then the quarantine would be over. Goodbye. Good luck.